Now we'll be discussing about the design issues which is related with the availability. Now, availability is also one of the important issue which is related with the designing of the distributed file system, because it may be possible that the server are going to failure or the communication network is going to failure, and if the server or the communication system is going to failure, it will create a effectiveness on the availability of the file which the client used to require for a certain purpose. So just to make the file available every time, whatever the user or the client is in requirement or the process is in requirement, the replication is the primary mechanism which can be used for enhancing the availability of the file. Because if a particular server which is on which the file is residing is going to fail, and if it is replicated to another server which is live, that can be made more effective availability of the file. So first of all, we will be discussing about the replication. So in this replication, what we do, there are many copies called the replica of the files, which are maintained at the different servers. And of course, this process is good enough for the as far as the availability of the files are concerned, but it is an expensive process because extra storage space is required to store the replica, as well as it is not only the file which has to be stored. For that, we require in space. It is also necessary that to maintain all the replica up to date. So this is also an overhead which is coming into the picture if we are using the replication process. So the problem which is related with the replication is that, first of all, is how to keep the replicas or the replication of the files consistent. And second, the second problem is how to detect the inconsistencies among the different replicas of the file, as well as how to recover from these inconsistencies. So these are the two problems which are associated with the replication of the files. So now there may be situations that that will be causing the inconsistency among the replicas. It may be possible that the first question may be that the replica is not able to be updated because of the failure of the server which is storing that replica. And second may be all the file server which are storing the replica of the file. It may be possible that it may not be reachable from all the clients because of the partition of the network. As well as there may be other situations also that in replica which is made for the file, it is residing in the different partition, and they are updated very differently. So these are the problem which is related with the replication. Then the second part of the availability is the unit of replication. Now, the fundamental design issues in the replication is the unit of the replication, and the basic unit of that is the file. Now, this kind of unit allows the replication of only those files which are in high demand, which require higher availability. Now, if we are doing only for certain files which require higher availability, that makes the overall replica management more tougher. Because it may be possible that protection right associated with the directory have to be individually stored with each replica, and the replica of the file belonging to a common directory may not be having the common file servers. So therefore, it requires an extra name resolution to locate the replica, and in case the modification is being done to the directory or to the file. So the alternative approach is to the replica unit, that instead of using only few files which require the higher availability, why not the group of the files to be replicated uh, 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 to be replicated uh, as far as the single user or the server is concerned. Now, this group of the file is referred to as the volume, and uh, whenever we are referring, instead of certain files, we are referring group of the files, which is known as volume, which is considered as a volume. Then the replica becomes seems to be easy, because the replication management becomes easier in that particular case, because protection right can be associated with the volume instead of the individual files. And uh, so volume replication is good enough to make the replication possible, but uh, the disadvantage is that it is going to wasteful, as the user typically requires only the higher availability of the files. So if we are doing the replication of all the files which are available on the server, that is going to waste the storage space as far as the client memory is concerned. So what we have to do, we have to make certain compromise and go for another scheme which has the advantage of both the schemes. The schemes which is using basic unit as the file, or second scheme which is using as a volume. And this scheme says that that instead of constituting, instead of going for the single file or for going for the volume, why not to make a group of the file, and that group of the file is known as primary pack, which is required by a certain client. So a replica of the primary pack, uh, which is a group of the file, it is going to be allowed, and it contains only the subset of the files, whatever is available on the server side. So with this arrangement, a different degree of replication of each file in the primary pack can be obtained, and thus by creating one or more packs of the primary packs. So in this way, the availability can be done, but it is an important issue as far as the distributed file system is concerned. Now the next issue is the scalability. Now the issue of the scalability deals with the suitability of the design of the system, so that it will be able to cater the demands of the growing system. Number of clients are going to become more, for number of file servers are increasing. So as far as the distributed systems are concerned, the distributed file systems are concerned, we work in the client server organization, because we normally use this client server approach to structure the distributed file system. And we know that caching is a process by which we are able to reduce the network latency, as well as we are going to reduce the server load, because in the, if we are using the client server structure, and that is the caching of the individual file is going to improve the response time as far as the client is concerned. So, but with the caching, we have a problem, that is the cache consistency problem, because there are many clients who will be caching the file and updating the file. So in that particular case, we have seen that server initiated validation is most commonly used approach to just to maintain the cache consistency. But in this particular scheme, the server keeps the track. It is always going to check that how many clients with whom the file is shared, and this information has to be stored on the server itself. So this information becomes that how many clients are using the file. This becomes the part of the server, and it is known as server state. So if the if the system is growing, if the number of clients are increasing, it is growing larger and larger, then the size of the server state in which it is keeping the record, and since it is a server initiated process, so the invalidation is also going to increase. So two things are going to increase. First is the server state, as well as the load due to the invalidation, just because of the server initiated cache validation scheme. Now the server state and the server load that can be reduced by exploiting the knowledge that how many are the users of the file, how the files are being used, And in the important observation in this particular regard is that which is very widely used, are the shared file are accessed in the read-only mode. If the shared file are used in the read-only mode, then it is not necessary to maintain the server state. As well as the invalidation process will also not happen. So in that particular case, there is no need to check the validity and whether the client which is having the information, it is the old one or it is up to date. And it is not necessary to maintain the list of the clients at the server side for the invalidation process. Now, another observation is that the data required, whatever data is required by the client, is most of the time it is available in its client's cache and other clients' cache. So it may be possible that a particular client who is in requirement of certain kind of file or the data, and those clients who are already cached those information in the form of a file at that particular cache. So that client may contact to the other client's cache which is having that particular file. But this particular observation is going to raise the question that how a client will be able to find those data, to find those clients which are having the required data. So another scheme has been proposed that client can fetch the other client cache by a certain scheme, and that scheme may be that suppose there are n number of clients who are being served by a server, and new n dash clients can be informed that they can obtain the data from the first n clients which are already cached. Now these n dash clients will also serve n double dash clients and so on. So this is a kind of a hierarchy which can be framed, because the first n clients are already caching something. N dash clients are informed that such type of files are available with the n clients, and if some more n dash double dash clients are want the same file, they can work with the n dash, and through n dash they can work for the n. So the hierarchy of who is serving from who is serving who is serving who forms a tree, and cache misses and invalidation message propagates up and down, where the each eternal node serves as a mini file server for its children. If n double dash is in requirement of a certain file, it will first contact the n dash because it is connected with the n dash. If n dash is in requirement of a certain file, it will be contacting with the n clients. So in this way, one client can fetch another client, those who are having a certain file. So by this, the load on the server will be able to reduce. The another point related with the scalability is about the structure of the process, because it is also going to play an important role in deciding that how many clients a server is going to support. If the server is designed for a single process, then many clients have to wait for a longer time. If it is busy, it is working, it is initiating its disk operations. So this kind of wait can be avoided if the separate process is assigned to each client. And in this particular case, the significant overhead due to the frequent context switches to handle the request from the different clients can slow down the server. So anyhow, this scalability is the very important issue, and this has to be taken care while designing the distributed file system. Now, the next design issue is concerned with the semantics. Now, semantics of a file system, it is going to characterize the effect by which the files are being accessed. Now, the basic semantics which can be easily understood and it is very easy to handle is the read operation, and will return the data is stored due to the latest write operation. Now, whenever a read operation is being done, the server has to return only those stored data which is latestly written, means updated. So this particular semantics, this guaranteeing of this particular semantics in the distributed file system is very important, and it is going to employ the caching scheme. And we know that caching scheme is an expensive one as well as it is a difficult one. So let us consider a file system which is employing the server initiated cache invalidation, which is going to give the guarantee about the cache consistency. So in this particular system, because of the communication delay or the invalidation has not occurred immediately after the updates are being done, or the before the read operation has been occurred by a certain client. So just to give the guarantee about the semantics, all the read and the write operation from the various clients will have to go through the server, or sharing will have to be disallowed either by the server or by using the locks by the applications. Now, in the first approach, in which all the reads and the writes operation of the clients have to go through the server. In this particular approach, the server can potentially become the bottleneck, and the overhead will also increase, and overhead will be high because there will be high traffic between the server and the client. So, and the second approach in which we are going to we are going to disallow either by the server or by the user use of the locks by the application. This is going to be create a problem that the file may not be available to a certain clients. So these were the 7 different design issues which are related with the distributed file system. So based on these issues, let us now discuss with the mechanism for building the distributed file system. And there are 5 important aspects which are related with the basic mechanism of distributed file system. The first is the mounting, caching, hints, bulk data transfer, and the encryption. So first one is the mounting. Now, this mount mechanism allows the binding together of the different file namespaces to form a single hierarchical structure namespace. A namespace which is called the collection of the files can be bounded or can be mounted at the eternal node, or the leaf of the namespace tree. Now, this particular figure is going to illustrate a namespace tree in which a node onto which the namespace is mounted is known as mount view. These are the space A and I. In this A and I are the mount point at which the directories which are stored at the server Y and server Z are mounted. Now, A and I are the internal nodes of the namespace server. Namespace tree, and the kernel is going to maintain the structure called the mount table, which maps the mount points to the appropriate storage devices. Now, in case of distributed file system, the file system which is maintained by the remote server are mounted on the client side or at the clients. And for this, we use 2 approaches to mount the information. The first one is the information is being mounted and which will be maintained by the client itself. And each client have to individually mount every required file system, whatever it is required by the client. Now, this approach is employed in network file system, that is Sun network file system, because each client can mount a file system at any node in the namespace tree, and every client need necessarily to see the identical namespace. Now, the second approach is to mount the information which will be maintained at the server, not by the client, in which it is possible that every client sees the identical namespace, and this particular system is used in the Sprite file system. So in this particular case, if the files are moved to the different server, the mount information need not need only be updated on the server itself. But in the case of first approach, in which we are using network file system, in which if the file system is moving from one client to another client, we have to make the updation from in the mount table, which is maintained by the client. So these are the two file system, which is giving the example that how the mounting is being done in network file system and in the mount and the sprite file system. In network file system, the mount table is being maintained by the client. In sprite file system, the mount table is maintained by the server. Now, second one is caching. Caching is we know the use of the caching, why we do the caching, what is the importance of caching. Of course, it is having certain demerits, but it is going to give a very important, it is going to play a very important role in getting the information in a lesser time if the client is in requirement. So it is a commonly employed, caching is commonly employed in the distributed file system just to reduce the delay. Delay in what? Delay in accessing the data. So what is done in file caching? A copy is stored of the copy of the file or the data, you can say, are stored at a remote file server. It is brought to the client whenever the client is going to refer it, whenever the client is in requirement of that. And subsequent access of that data is being performed locally at the client side, thereby reducing the accessing delay due to the network latency. So every time it has not to go to the server and ask for the file, and the file or the data is already brought to the client side, and subsequent accesses can be done from its cache. Now, caching is normally going to exploit the temporal locality of reference, which is exhibited by the different programs. And this temporal locality of the reference refers to the fact that a file recently accessed is likely to be accessed again and again in the near future. So data can be, now, whenever we are caching the data can be cached either in the main memory or in on the local disk. The data which is cached in the main memory will be available at the client side, whether it is cached in the main memory or in the local disk. And the advantage and the disadvantage of caching the data either in the main memory or the local disk, it has been already discussed when we were discussing the cache design issue of a distributed file system. Now, data can also be cached in the main memory of the server cache at the server side, just to reduce the disk access latency. Because whenever a client is in requirement of a certain information, and if the information is not available in the client cache, it will first search to the server cache. If it is not available, then only the server is going to check its disk to find out the data. So the cache can also be done, caching can also be done on the server's main memory. Now, whatever caching we are doing on the server main memory, now what kind of data blocks? Now, the data blocks includes those information, those blocks or those files or those data which are asked by the client. And these data, including the blocks which are swapped at the clients, as well as the data block that are contiguous to the blocks which is previously requested by the clients, as these data are more likely to be accessed in a very frequent manner. So the file system performance can be improved if we are using the cache scheme, since the accessing the remote disk is much slower in comparison to accessing the local memory or the local disk. Another important aspect of caching is that it is going to reduce the frequency of the accessing of the file server. It is going to reduce the load on the file server. It is going to reduce the load on the communication network. So it is going to improve the scalability of the system, file system. The third point is caching, hints. We have just discussed about the caching, which is going to improve the system performance by reducing the delay which used to happen while the client is accessing any data. But when multiple clients are going to use the same data files, and it is going to cache, and they are going to modify this shared data, then the problem of the cache consistency may arise. So before using the cache scheme, it must be guaranteed that the cache data must be valid. It should be up to date, so that whenever any client is going to update the information, the copy of the updated data must be available to the other clients also, as well as to the file server if it does not so. So if we want to make the guarantee of consistency while with the use of the caching, it is going to be an expensive process in the distributed file system, because it requires a very elaborate cooperation agreement. It requires a very effective collaboration in between the server and the client. So for that, another approach is being used, and that approach is to treat the cache data as hints. In this particular case, the cache data are not expected to be completely accurate. So, however, the valid cache entries is going to improve the performance substantially without without incurring any cost of maintaining the cache consistency. So this class of application, which is utilizing the hints, are those which can recover from discovering that the cache data are valid or it is invalid. So if we try to learn this thing with an example, that that after the name of a file or a directory is mapped to a particular physical object, the address of the object can be stored as a hint in the cache. So whenever we are using any file, or we are mapping any directory with the physical objects, the address of that object will be stored as a hint in the cache. So if the address is going to fail, if the address failed to match with the object in the following attempt, the cache address is going to be uh, uh, obsolete. It becomes obsolete. It is deleted from the cache. Now it is the duty of the file server is being consulted with the name server to determine the actual location of the file or the directory and update the cache. So this is how we can use the hints, which will be storing the address of the objects in the cache, so that it will be able to check whether the cache data is valid or not. Now the bulk data transfer is the next part. In bulk data transfer, the multiple consecutive data blocks are being transferred from server to the client instead of just single block transferred, which is referred by the client. Now this bulk data transfer is going to give the advantage because it is going to reduce the file access overhead by obtaining the multiple number of the blocks with a single seek. Because what happens when the client is in requirement of a certain file, it will be asking, and next time it will be requiring another file, it will be again asking. So it has to seek many times about the information regarding the file. So what is being done, instead of transferring only single file, why not to transfer the data or the file in bulk? And that is why it is the advantageous process. Now this bulk data transfer, which will be done in a single seek, and how it can be done by transmitting or formatting and transmitting the number of the large packets in a single context switch, so that it is going to reduce the number of needed acknowledgement. The third important aspect of the bulk data transfer, that it is going to exploit the fact that most of the files are accessed their entirety. Means the entire file instead of certain blocks, why not to transfer the entire file? So this is the fourth mechanism by which the distributed file system used to work. And the last one is the encryption, which is going to enforce the security as far as the distributed system is concerned. and it will be using a certain protocol called Needham-Schroeder protocol, which is used for the security. And these protocols are being used to make two things very important. We have certain rules which are related with the network security is concerned. Out of these out of these many principles of the security, it is going to authenticate the user. So before there is any communication which has to be established in between the two parties, whether it is a client or it is a client and the server, they have to establish, they have to be the communication should be very secure. And this to maintain, and two entities want to secure their communication, can be done if they are authenticating one and another. And for that, we will be using the Needham-Schroeder protocol. And this Needham-Schroeder protocol will be using an authentication server. I am just giving you the general idea that how Needham-Schroeder protocol used to work. This is the illustration in which we have two parties who want to be in conversation. And this is the authentication server which is going to authenticate. So for this particular purpose, the sender will be sending its identity along with the server with which it wants to work, the identity of that, along with a random number that is called random nonce. Now, when this authentication server is going to receive these three information, it is going to issue a ticket, and it is going to encrypt this information, the whatever has been sent, and that information is the random number which has been sent by the A, Bob's identity, as well as the key with which they can start their work, and the information of the sender, the identity of the sender, as well as the key, which is encrypted by the key which is meant for the B. So that is why the whole information is encrypted by KA, and this information is encrypted by KB. So whenever this information is being received to Alice, now it is able to decrypt it because K is already available to A. So whenever K is available to A, it will be receiving its random nonce. So by this, it will be able to know that whatever random number it has been given to K, the authentication server, the same number has been received. And this information it cannot open because it is encrypted by KB, and KB is available with Bob. So it will send this information to Bob. So whenever Bob is receiving this, it will be having KB and it will be receiving this, it will decrypt it. Whenever it will be decrypting, the key will be available to him. Now with this, what it will do, it will generate its own random number, and that random number will be encrypted by a particular key, and that is KAB. That the key is a KAB. This key and this key is KAB. So this KAB is already having with Alice. This KAB is already having with Alice. So Bob also. So it will send its random value to it, to the sender. And this, since KAB is already available, so it will decrypt it, it will find RB, and it will send a verification message by encrypting it. RB, whatever random value it has received, it will reduce it by 1 and encrypt it and send it to the Bob. So in this way, authentication can be done. A and B will be able to show that they are communicating with each other by exchanging a random value. So this encryption mechanism is also used for this particular purpose. So this is all about the distributed file system.